Hi there, this is Ingo from RA, and today I will show you how to use DiagRA X for bus stimulation. First of all, what you will learn in this video. What does bus stimulation mean in DiagRA X? How to set up a transmission source in your workspace? How to define a virtual message and send it? And how to automate sending messages via event triggers. So what is bus stimulation? With the bus stimulation feature, DiagRA X becomes an active bus participant. You can configure DiagRA X to send CAN messages on demand, cyclically or via event triggers. This can be very helpful, for example, for waking up a certain bus participant, or quickly triggering an emergency switch in a test bench, or remotely switching some relay in an external system, or cyclically switching through the vehicle's drive or powertrain modes, or more generically for stimulating a system by changing its input parameters, which may be temperatures, voltages, state conditions, or other kind of values. What all these cases have in common is the requirement that the data must be understood by the system being stimulated. Sender and receiver must agree on a common definition. For CAN, this definition is mostly given in a DBC file. In DiagRA X, this definition is specified via so-called virtual messages. Virtual messages are a subtype of virtual variables and therefore are defined by the user and only exist within the scope of DiagRA X. You can define a virtual message manually or based on a DBC definition. And you can define and send any number of virtual messages at the same time. For example, you can define multiple virtual messages, each reflecting one specific value of the same DBC message, and then send them quickly on demand or cyclically in a round-robin scheme. As always, we start with an empty workspace and experiment, and create the sources and visualizers we need. If you are not yet familiar with the general concepts of DiagRA X, have a look at our introductory video on DiagRA X, which you can find on our website. Now, for sending CAN messages, we need a source which has a CAN-based protocol and which is connected to a CAN interface. Both source types measurement device as well as CAN bus can be used. I will create a new CAN bus source with the name sender and with a DBC file defining some messages which are known to the system I want to stimulate. For a quick first test without hardware, as CAN interface, I choose a virtual CAN channel. To get virtual CAN channels working on your computer, I recommend installing the Quasar CAN driver, which contains the virtual CAN driver which I use in this tutorial. As in the test we will just send and not receive any data with this source, I will deactivate the Keep Alive watchdog to not get any undesired notifications. That's it for the workspace setup. In the experiment for sending CAN messages, we need a special visualizer called Scheduler Visualizer. I simply create an empty experiment and add the visualizer in the worksheet. As we will need an oscilloscope and measurement table for validating the sent signals, I also add those to the worksheet. As an example, I will use a simple message defined in my DBC, which consists of just one signal telling the ECU to do an emergency stop. This message I can use anytime on demand or later as an automatically triggered safety switch. The creation is basically the same as defining virtual signals. In the Variables Manager, under Virtual Variables, I select CAN messages and then Add Virtual Message. I put in a name and hit Enter. On the right side you can see the properties of the new virtual message. By default, CAN is selected as the message type. That's okay for me, because I don't want to send more than 8 bytes of data, for which I would have to select CANFD instead. Also, the transmission source is already set to my previously defined sender source, which is exactly what I want. As the message I want to send is defined in the sender source's DBC file, All I need to do is to select this message as the definition. Given the definition, DiagRA X can derive most of the settings required. So to set up the virtual message definition, I only have to set the actual data bytes and optionally the raster I want to use for cyclical sending. To send the virtual message, I must assign it to the scheduler visualizer. You can assign any number of virtual messages to any number of scheduler visualizers in your experiment. This way you keep control over the stimulation on all your worksheets. For this session, one scheduler visualizer is enough though. Quick tip: see what happens if you try to assign a DBC message directly to the scheduler visualizer. DiagRA X will kindly ask you whether you want to create a new virtual message based on the given message definition, or if you rather like to reuse an existing one. I will just create another one for the same message, which we will use later for resetting the emergency stop. Use this little shortcut to speed up the preparation steps for sending DBC messages. Now back on the worksheet, I will show you what you can do with the scheduler visualizer. As you see, the assigned virtual message is selected in the top area, and in the bottom the signals defined in DBC are shown with the physical value corresponding to the data bytes of the selected message. The status LED of the message tells me whether I can send it or not. Green means I can send it. If I hit the first button to the left, the message is sent exactly once. The little play button will start the scheduling of this message. That means the message will be sent repeatedly in the defined raster. Sending, by the way, is possible once the transmission source is connected. There is no need for a running measurement session. To see and prove that the data in fact was sent, next I will prepare a measurement session for it. As with most CAN drivers, it is not possible to use one channel to receive the data which you just sent onto it. That means for measuring the signals, I need to use a separate CAN channel. Luckily, the Quasar virtual CAN driver supports multiple channels, which are virtually connected to each other via a virtual CAN bus. To set this up, I duplicate my sender source, change its name to receiver, and assign different virtual CAN channel as its interface. Again, as there will be no communication on the bus other than the messages I sent explicitly, I will switch off Keep Alive also for the receiver source. On the worksheet, I already created a measurement table and an oscilloscope for measuring the sent signals. In the Variables Manager, I navigate to the receiver source and assign the signals of the original DBC message to the still empty measurement visualizers. Back on the worksheet, I start the measurement as well as the scheduling, and I can instantly see the values appearing in the measurement visualizers. As the scheduler will always take the newest defined value for sending, I can even change values effectively during scheduling. Now that you have seen and understood the basic concept of scheduling CAN messages in DiagRA X, I will show you how to use this concept for automating a stimulation. In my example, I will use event triggers to send the stop signal to the ECU when the engine temperature gets too high. For getting the temperature, I quickly set up the ECU as a new source and assign the measurement value to my visualizers. Now I can go to the event setup and create a new event action. Here I select Send CAN message and my stop message. Under Execute, I define the condition under which I want the message to be sent. As an example, I want to send it if the engine temperature of my ECU is higher than 140 degrees Celsius. Per default, the message will just be sent once and the action will be deactivated. If I define a reset condition, once fulfilled, the action is reset and again waits for the execute condition to become true. The corresponding states of the action are shown with a black, green and red LED. If you start the measurement, the green LED indicates that the action is active. When the temperature value passes 140, the LED is shown red, meaning the message was sent, and black shortly after to indicate that the action is inactive. After the reset condition was fulfilled, it turns green again and the process starts all over again. With these simple steps, you can accomplish also more complex automations. For example, I can define another event action using my reset message to tell the ECU to start again when the temperature is low enough. Concurrent event-triggered stimulations result in the engine being heated up and cooled down in an automated loop. Before wrapping up this tutorial, I have some more notes for you to take. First, it is always better to have a message definition in DBC rather than sending raw bytes in DiagRA X and therefore using an implicit definition. With an explicit definition, DiagRA X can help you validate the data by showing the individual signal values offline or even through remeasuring them online. Second, use multiple scheduler visualizers, one on each worksheet where you need to stimulate and observe data at the same time. All scheduler visualizers will refer to and reuse the same virtual messages. You can, for example, start a scheduling in one visualizer and change the sent values in another. And third, if you use a CAN channel only for sending, make sure to switch off the Keep Alive watchdog in the protocol settings to avoid error messages. So let's recap what we covered in this video. I explained what bus stimulation is about, how you set up a transmission source in your workspace, how you can define virtual messages and send them, and finally, how you can use virtual messages in combination with event-triggered actions to automate bus stimulation. That's it for this video. If you have further questions or suggestions to enhance the bus stimulation feature in DiagRA X, please feel free to contact us. Take care and thanks for watching.